Hello everyone, welcome to the second part of our video on factorizing monic quadratic trinomials. Now, I have started this video on the very last bit of the previous video where we applied this idea of the patterns we saw to get really quickly to an answer and then checking that with this middle step. If you remember, I wrote here, the middle step is important. So I've left this in here. But what we have been doing in the previous video, in the attempts of looking for a pattern, we have been expanding. So expansion goes down the line. So when I go down to here and down to here, this is a process of expansion. We're starting from a binomial product, getting to an expanded quadratic trinomial. Now, what we're going to be doing now is we want to factorize. So we want to go the other way. And factorizing, if you remember from all of our previous videos, it starts with an expression and we are trying to go backwards to break this down into a factorized form. So going on with the examples, the things we observed, we said that, cool, this middle term here, this coefficient, was a sum of the two whole numbers, the two integers in my binomial products, and this ended up being the product of those two numbers. So once we find those terms, they end up, because if you think about it, we're going the other way now. So before we get to this final step here, where we end up factorizing, we need to first take those numbers and display them here. So we need to break the 10 up into those two numbers. So if we look at it from bottom and going the other way, the two numbers, first we needed to find, well, what numbers add to give me 10? Whoops. What numbers add to give me 10 and multiply to give me 24? And then we can pop those in as the coefficients of x, because that's what ended up happening every single time. So we can use that pattern to establish a procedure, a process for factorizing now. So what we're going to do in this video is we are going to go through a series of examples, and I'm going to give you the long way of doing this because I believe it's important to help you actually understand it. There are a couple of shortcut ways here. This channel has always been long form. I'm going to show you the long way and a hopefully more intuitive way to approach these types of things. So we're going to look at a series of questions here. I am going to write the first one up here. X squared plus 7x plus 10. Now, based on what we've observed, our factors, so by that I mean these numbers here, these missing numbers we want to fill, those factors, so our factors should, because the pattern we observed going all the way through, these should always add to the coefficient of x, so in other words, this b, so all of these were in the form ax squared plus bx plus c. So they should add to the coefficient of x and multiply to the constant. So what I might do actually to refer back to this first form of all Monic Quadratic Trinomials, this ax squared plus bx plus c, I'll put those pronumerals in brackets here. So these two factors must add to give us the coefficient of x, so this pronumeral b, and multiply to give us the constant, this pronumeral c. So we have a head start. We know what to expect based on these patterns we observed. So if I write out my quadratic expression here, we want to find this bit down here, those two numbers. And we do that by considering the product, that's what P stands for, and the sum, that's what the S stands for. So what we want to do here, I should say, is we want to find two numbers that add to give me 7 and multiply to give me 10. So let's think of the numbers first that multiply to give me 10. I can have, let's say, 10 and 1. Or I could have 5 times 2. These are the two factors that give me 10. So 10 times 1, that's one of those. But notice that if I were to add 10 and 1, that would give me 11, which is not the number here. So this is not the factor that I'm looking for. Now let's consider the second one. Now 5 and 2 multiply to give me 10. I've already established that. But if I add 5 and 2, those give me 7 here. So I'm going to fill this in here. So my product should be 10, my sum should be 7. So my factors, the two numbers, those are going to be 5 and 2. Those are my factors here, 5 and 2. So that means that these two numbers, like we've noticed in the previous patterns, those are going to be the ones here in the middle, right? Notice here, 6 and 4 multiply to give me 24. They add to give me 10. So this is that in-between step. That's why I included it, because now we can split up, because remember, we're doing the same thing just in the opposite direction. So everything we did in one way, we want to follow that same route back to where we started. So what I'm going to do here is I'm going to split up 7x into, because we're going the opposite direction, I'm going to split that up into 5x plus 2x. I have done nothing that violates maths here, have I? Because 7x, another way to write that is just 5x plus 2x. Now, what can I do here to get from this step back to my binomial product, my factorized form? Well, this is where we need to consult some of the skills we've learnt before. Because notice, we've gone from 3 terms here in my first expression to 4 terms in my next one. Now, what's something we could do when we had these 4 terms? If you think back to a couple of videos ago, we can consider these as 2 pairs, and we can group the pairs as well. So what we're going to do is we're going to consider each of these pairs separately. Remember before I did this thing where I was like pair 1, pair 2, and I did these separately to factorize. Now I'm going to do this here a bit quicker because we've already covered this. This first pair becomes x outside of x plus 5. And because x is the common factor in both of these things here, Now, what's the common factor from my other pair? Well, that's going to be 2. 2 goes into both 2x and 10. So I can pull that out the front. Plus 2 outside of x plus 5. Now, we are looking at our binomial factorization. Because remember now, we have a common factor to both terms, both this term and both this expression and the second one. So I'm going to pull out this x plus 5 out the front. And when I take that out of both terms as a common factor, what am I left with? Well, I'm left with my x here and my positive 2. I get x plus 5, x plus 2. And this is my final factorized form of this quadratic trinomial, x squared plus 7x plus 10. I have reduced this, going the other way, to a binomial product. And once again, we can check this using FOIL to see if I've done it right. I'll do one of these now here with you. So just to check I've done it right, with any factorization, remember, we can check by re-expanding. So if I were to re-expand this, I get x squared plus 2x plus 5x plus 10. I can collect the like terms, x squared plus 7x plus 10. I end up where I started. So I've done the factorization correctly. Now, some of you may have observed this and you've gone, oh, wait a minute, wouldn't it just be easier if I said, okay, once I found my factors, 5 and 2, I just know that they go here. Now that's the shortcut way I was talking about. Some people teach it like this, but you're not really taking in how we're actually getting to that point. How we're actually doing this goes a lot deeper than just going, well, I already know the pattern, I have my factors, I'll just sub them in here because I know that those are my empty spaces like I had up here. But doing it this way that I've laid out for you here, using our factorizations we've learned, using our grouping in pairs, using our binomial factorization, we are tying together all of the techniques we've been honing and building up to for this video. It would be a waste of time, a waste of all of that context for us to just copy paste them here in the end like we've done. I want to hopefully give you guys an appreciation for how much we are actually piecing together these techniques we've been doing this whole time. Okay, now let's look at another example. So I have, for example, 2, and all of these videos, or all of these examples I should say, I'm going to do in this longer way to give you an idea for how this stuff actually works. So for example 2, I have x squared plus 2x minus 8. Okay, now I want to do the same thing as before. I want to consider what my product is, what my sum is, and then what my factors should be. So I want 2 numbers that multiply to give me -8. So my product is -8. And I want 2 numbers that sum, that add together to give me +2. So I'm going to put that in here. And what I want is 2 numbers that multiply to give me -8 and add to give me 2. So let's have a think about what these could be. Now, a hint for these types of questions, because a lot of students get to these and they get a little bit overwhelmed, but all we need to do, and a little trick that can help us, is to consider the sign of our product. That's going to give us a pretty big hint as to how the factors may look. Now think about when numbers multiply, when positive and negative numbers multiply, when positive, positive, when negative, negative. The product we get gives us a hint as to the sign of the numbers. So the product here is negative, therefore the numbers that the two factors that are multiplying together, one of them has to be positive and one of them has to be negative. That's a hint, right? So, and we can also consider the sign of my sum. The sign of my sum is positive. So that tells me that that one of the products, so the one of the factors with the bigger magnitude, the larger, no matter what sign, is going to be the positive one. So the factor larger magnitude is positive, because when we add that to a negative, we're still going to get a positive here. Now, let me show you why that's important. Let's consider negative 8. So the factors of negative 8 are, let's write them down here. So negative 8. The factors could be, because here we have a lot of different combinations. It could be 8, negative 1, negative 1, 8, 2, negative 4, negative 2, 4. All right, it's going to be any one of these. Now, we can rule out the top two, this one and this one. Why? Because whether I do 8 minus 1, that's going to give me 7, or negative 1 plus, oh, sorry, I've done these the wrong way around, or 1 and negative 8. Or negative 8 plus 1, that's going to give me minus 7. But we have a 2 here for my sum. So it's going to be neither of these. I have to choose between either this one or this one. Now, this is where this hint comes in handy. The factor with the larger magnitude, so the 4 instead of the 2, is going to be positive. So this one here. Why is that important? Because if I took 2 and added negative 4 to that, if the number with the bigger magnitude 4 is the negative one, that's going to give me negative 2, which is not what I want, because I want a positive 2. So I can always look for these hints. That means I can rule out also this one here. So the factor that I want to choose is going to be negative 2 and 4, because minus 2 plus 4 gives me positive 2, and that's what, that is what I am looking for here. So my factors are going to be 4 and negative 2, right? The number with the larger magnitude of these two, 4, is the positive one. Hence a positive b, which is the coefficient of x. All right, now that we know these, we can break down x squared plus 2x minus 8. Let me write that again. So x squared minus 2x plus 8. I can break down this negative 2x into, my x squared stays the same. Negative 2x, I'm breaking into plus 4x minus 2x. Remember, I haven't violated anything mathematically. Another, it's x squared plus 2x minus 8. I've got my signs the other way around. Let's double check that. X squared plus 2x minus 8. I haven't violated anything here because I can make 2x, positive 2x, out of 4x minus 2x. What this allows me to do now is to simply group my two pairs. So what I get here is going to be working through these one by one. So x squared plus 4x, the common factor is x, and here I get x plus 4. Okay, and then what I'm going to do here is I'm going to pull out my common factor here. I keep writing plus 8. Sorry guys, I'm confusing myself. X squared plus 4x minus 2x minus 8. Okay, so with our grouping in pairs now, I want a factor that goes into both negative 2x and negative 8. Now, I'm going to deliberately make a mistake here to revise something we've talked about before. Say I took the factor of positive 2 out, and then that would leave me with minus x minus 4. This thing cannot be factorized. Remember, we did this in a previous video because I no longer have a binomial factor. The binomials are different, so I can't factorize those. So I want to get x plus 4 in here. So instead of picking positive 2 as my factor, I'm going to pick negative 2. I'm going to do a bit of mathematical manipulation, and that will change the two signs here. I talked about this more at length in the grouping in pairs video. If this is a bit confusing, please check that one out. Now I have a common binomial factor for both of these things here. So I'm going to pull that out the front. So I have x plus 4, and in my next one, I have x and negative 2. So I'm figuring out how many times does x plus 4 go into x outside of x plus 4. It goes into it x times, and for this other one, it goes into it negative 2 times. And that is my factorized form of my quadratic trinomial. So you can have a go at just re-expanding this one if you'd like to practice, but that is the factorized form. Now let's try one more question. We're going to do it in the same way. Let's try one that's slightly different to what we've been doing here. All right, let's try this one. X squared minus 11x plus 18. This one is also slightly different, and this example is to show you why it's important to consider the signs of my product, sum, and factor. They're going to do a lot to inform my choice of factors. Now here I can see my product is positive 18. That sign's important. My sum is negative 11. That negative is important, and I want to find the factors now. So I have a positive product but a negative sum. So the only way I can get a positive product and a negative sum is if both my factors are negative. Because if both of these were positive to get positive 18, there's no way I can make a negative number for my sum. But I can make a negative number in my sum only if I have two negatives. And I need two negatives to ensure that I get a positive product. So let me actually write that down here. Both factors are negative. A very important thing to notice here. Okay, so let's consider my factors of 18. And I'm going to make a slightly bigger box here, all using negative numbers. So I have negative 1, negative 18. I have negative 9, negative 2, and I have negative 6, negative 3. Okay, so I want, when I subtract one factor from the other, that I'm going to get negative 11. So this first one immediately we can rule out, because minus 1 minus 18 gives me minus 19, that's wrong, as well as this last one, minus 6 minus 3, or minus 3 minus 6 gives me minus 9. That is incorrect. So my negative 9, negative 2 is going to be my pair of factors. So I have negative 9, negative 2. So this is where taking a quick moment to consider the signs makes our life a lot easier when we want to factorize. So getting rid of this, now we know our factors, I can break up my original expression, x squared minus 11x plus 18, into the two factors. So I'm going to break up negative 11x into x squared minus 9x minus 2x plus 18. So I finally, like we've seen every single time, I wind up with 4 terms which I can group in pairs. So x squared minus 9, I'm going to pull out the common factor of x, and I get x minus 9. And from this second pair, I'm going to pull out negative 2, and that is going to give me x minus 9. Because these two negatives, I wanted the negative factor because the two negatives give me the positive up here. And now I have my binomial factorization that I can do. So x minus 9 is a common factor to both this expression and this expression. So I'm going to pull that out. I have x minus 9. And here, I wind up with, when I take that out from both, x from the first one and minus 2 from the next one. You guys can expand this to double check I've done it right. If I haven't, please let me know. But that is how we can factorize these monic quadratic trinomials. We are bringing together everything we have done so far, and I would encourage you always to do this the longer way. It's good practice for factorization in general, and it is also an important way to just apply everything we've learned so far. Why do it if why skip past it? If we've spent all this time learning about it, we want to apply everything we've learned. And that is how we can think about these types of factorizations. Now in the next video, we are going to finish off our quadratic trinomials and look at this idea of factorizing non-monic. So doing these factorizations when the coefficient in front of x squared isn't 1, for example, maybe it's 3 or any other number. But I'll see you there. We're going to finish off this topic there, and then we'll finish off with algebraic fractions. But thank you so much for joining me. I'll see you in the next video.